Topic 8, Superposition, Part 7, Diffraction Grating and Formulas. What is diffraction grating? A diffraction grating consists of many narrow parallel slits. One way in which these slits are produced is by ruling lines on a sheet of glass using a diamond. Typically, there may be 1,000 lines or 1,000 slits per centimeter of the grating. The greater the number of slits, the greater the brightness, because there's more light coming through. However, the lesser the number of fringes that will be seen. So instead of using 2 slits, as in the case of double slit interference, here we are using multiple slits for the experiment. These are pictures and diagrams showing diffraction grating. Let's look at this one here. These are 5 representative slits producing 5 sets of waves interfering with each other. As a result, antinodal lines like these ones here and nodal lines, which are not shown, are produced. This center one is the 0 order maximum, then 1st order maximum, 2nd or 3rd order maximum. These 2 diagrams once again show the interference pattern produced by diffraction grating. Look at this one here. A ray of monochromatic light is incident on a diffraction grating here, and as a result there is interference pattern produced, giving rise to antinodal lines, and in between them nodal lines. This is the central maximum, 0 order, 1st order, 2nd order, and so on. Likewise here. First of all, the distance between 2 adjacent slits is called d. And angle theta here is the angle at which a particular line, either antinodal line or nodal line, lies in relation to the center line. This diagram is showing that the path difference between 2 adjacent slits like this one and that one is exactly 1 wavelength, and so all these waves are advancing towards the 1st order maximum, for which the path difference is 1 wavelength. We use letter D to represent distance between 2 slits or 2 neighboring slits. Like from this one to that one is D, from this one to this one is D. Capital N stands for the number of lines or the number of slits per meter, and the relationship between D and capital N is this: one is the reciprocal of the other. You can read through all this, but a couple of main points. First one, the path difference between corresponding rays from any 2 neighboring slits is equal to d times sine theta, and d sine theta is equal to the order number times the wavelength for the particular line, whether it's antinodal line or nodal line. The value of n, which is the order number, and hence the total number of orders of the diffracted light, is governed by the fact that the maximum value of sine theta is 1, as we all know, when theta is 90 degrees. Here is an example for which there are answers, which are found on the next slide. You can go through these answers yourself. Try this example if you have time. Here is another example you can try. The diffraction grating experiment will be done in class. What happens if you use white light in the place of monochromatic light on a diffraction grating? This is what you get. Where the central maximum is, you get white light because all the 7 colors of light get there. You get white. Then, for the first order maximum, you get all these 7 colors spread out. Here's one, here's another one. Every color has got its own angle theta. Similarly, for other orders of maxima, you also get rainbow colors. Front-on view of the diffraction of rainbow colors. This is a pattern you get when you use white light. In the middle here is white, central maximum, where all the 7 colors mix. Then to one side you have first order maximum here, second order maximum here, and third order. In between there are the dark fringes, this one here and this one here. When you use green light, of course you only get green colors. Here is central maximum, first order, second order, third order. Likewise on the side. Here is a formula for double slit interference. Here's a formula for diffraction grating or multiple slit interference.